So now let's continue on with ACI transit routing. So let's take a look at ACI Fabric as a transit network. So we have a lot of different reasons why we might want to use ACI as a transit fabric, possibly simply exchanging routes between IBGP neighbors that are ultimately our eBGP external routers, such as ASR9Ks. We might want to actually do some routing with Linux or AS400 or other mainframes. We may want to exchange routes with various MPLS or other WAN type circuits back to our enterprise network, back to branch offices, and have those exchange routes with other devices, other routers that are connected to our ACI fabric. So we may have quite a few situations where we want to ingest routes into the fabric and then also advertise those same prefixes back outside the fabric to different routers. In this portion of the module, we're going to begin taking a look at how to configure that and some things to consider. So first of all, let's take a look at some current limitations to consider. We do, at the time at least of this recording, with ACI 1.1.10, or J was the previous release, we do have some current limitations. So we do have, in terms of the number of tenants or VRFs, essentially per leaf and per fabric, we do have a limitation of 100 per leaf or 500 per fabric. Now, there can always be some special cases. So if you do have a use case that is higher than this number, you're certainly welcome to contact Cisco. You can contact Lumos as well, and we can discuss your solutions with Cisco. And they do have scalability testing that they can take your specific use case and test that against the higher numbers that you need to be able to support. So don't rule out this as this is for general consumption. You can go by these rules and certainly be safe. But if you have a special use case, you can always bring that up with Lumos, with Cisco, and we can get that scalability testing done. We also have, as I mentioned, a number of L3 contexts or VRFs. We have the number of L3 external routed networks, so L3 outs that we can configure. So we can have a total of 100 L3 outs per leaf, and really that goes across all tenants. So I could have, you'll notice here that I can have the number of L3 outs per VRF. That's not necessarily per tenant, but per VRF is currently limited to 3 per leaf and also really 3 per fabric wide, but that's per VRF. So I could have essentially 33 VRFs, each with 3 L3 outs, or any combination therein that would get me to 100 L3 outs per leaf, or again, 500 per fabric wide. Now, number of protocol peers. So if I form neighbor adjacencies with OSPF or BGP neighbors, I have 100 neighbors that I can have per leaf, or again, 500 per fabric. So you begin to see a pattern here. And then I also have the number of L3 out EPGs per L3 out. So what do we mean by this? These are the subnets. And again, remember, I can have multiple subnets or multiple prefixes within a single L3 out EPG. So when I create an EPG, it's going to be used as a representation of either one or an aggregate or multiple specific prefixes. So I can have as many prefixes as I want in that L3 out EPG, but currently I can have 3 EPGs per L3 out. So I've certainly done testing, and the capability is there to do many more. This is just the verified scalability numbers. Also note the number of IPv4 prefixes. We can only have 10,000 either per leaf or fabric wide. So this is a current limitation. Do keep in mind this does preclude us from having the entire internet BGP routing table of roughly 580,000 or 600,000 prefixes, obviously. So we aren't going to be using ACI today as a true eBGP as one of the leafs, as a true eBGP peer out to the internet, unless we could use it as long as we're only advertising our prefixes out and essentially getting in from the carrier a default route. So as long as we're only getting a default route, we could use it like that. We still recommend having at a minimum a pair of ASR 1Ks, maybe 1004s or something like that outside your fabric, or if you need much more higher speed, granular control, you can have much larger routers as you need to. So in terms of IPv6 prefixes, we can have 5200/2500, and you see the note down at the bottom. 5000 is for less than /64 prefixes, or roughly 1000 for / or greater than /64 prefixes. Now, how do we allow route redistribution, or what protocols are allowed to redistribute into other protocols? We've got a nice matrix here. So first of all, take a look on the left column, and you see that OSPF pretty much works with everything. It obviously works with itself. We can redistribute into IBGP that is running over top of OSPF. We can redistribute into eBGP running over top of OSPF. IBGP over static or direct connection, eBGP over direct connection. We can redistribute into EIGRP, and we can redistribute OSPF routes, or really advertise them through static routes, or actually create static routes based on those. So if we take a look at IBGP over OSPF, it obviously works with OSPF. We can also redistribute from IBGP into eBGP over a direct connection, but not something like eBGP over OSPF, as well as static routes. So you do see probably more red here than anything. Notice probably the least compatible is, surprisingly, the Cisco proprietary, or their own homegrown protocol of Enhanced Interior Gateway Routing Protocol, or EIGRP. Surprisingly, we don't support IGRP. Anyway, you had to be around a long time to remember that one. At any rate, actually EIGRP, if we remember back to some things I said earlier, ACI 1.0, 103, 104, and older versions did not support EIGRP. It also did not support eBGP, or external BGP. It only supported IBGP, where essentially the external BGP peer had to be the same ASN as our ACI fabric running MPBGP. So even though we're running MPBGP, it's still BGP, right? So we can do IBGP peerings, we can do eBGP peerings, and we only supported previously IBGP, OSPF, and static routes. So we do have EIGRP support here. However, you notice that we cannot even learn a route through EIGRP and redistribute it back to EIGRP on another neighbor relationship. So it has the least capabilities. I wouldn't really recommend using it, but you have that option. But if you need two separate EIGRP routes, and this is not like, neighborship to two different EIGRP routers in the same L3 out. This is two separate L3 outs, either in the same VRF or in different VRFs if we're doing VRF route leaking, which we talked a little bit about earlier, but we'll go back over now in this L3 section. We can't do the route redistribution from EIGRP to EIGRP. We can from EIGRP to OSPF, and like I said, OSPF can really do anything. Static routes have the next most flexibility. The only thing we can't take is a static route that we created and redistribute that to eBGP over OSPF, but we can do it to a direct connection, and we also can't take a static route and redistribute that through EIGRP. So there are some limitations. OSPF is your best bet. IBGP is probably your next best bet. It's had the most support for the longest period of time. And static routes are really your next best bet as well. While I'm here, I should also note one other thing, which is that for all of these protocols, OSPF, IBGP, eBGP, and static routes, we have support for IPv4 and IPv6. EIGRP, we only have support for IPv4. So all of them have dual stack except for EIGRP, where we only currently have IPv4. I believe more support will be added for that in the future, but in order to get it to market, a few people were asking for EIGRP. Truth is, I'd say 95% of the companies that I go to and do installations use OSPF. By the way, it should probably be noted here, something that's obviously lacking is ISIS. So we do run intermediate system to intermediate system inside the ACI fabric, but we currently don't support advertising or learning prefixes or doing any sort of neighbor relationship with other ISIS routers outside the fabric. So currently it's only used for internal communications. So really most of the time, in fact, I would venture to say I haven't run into any enterprises that I've worked with that run ISIS. Certainly many carriers do, but typically they're willing to do an OSPF adjacency or BGP adjacency and then redistribute that into ISIS if need be. So now let's take a look at ACI transit routing and how to configure this to allow all routes that we are learning in or back outside of the fabric to another peering. So here's our sample layer 3 transit topology. We have 4 leafs, leaf 1, 2, 3, and 4, or 101, 102, 103, and 104. I'll just call them 1, 2, 3, and 4 to keep it a little simpler. And inside the fabric, we have a few public subnets, 11.11.11.0/24, 12.12.12.0/24, and connected to leaf 1 and 3, we have a pair of links on E129 and 30 on leaf 1, E129 and 130 on leaf 3, and those form our VPC. Why we chose to do that versus using leaf 2 and 3, I don't know, just how we happened to set it up at the time. But those form our VPC peer down to a single N7K. And the N7K is just a single N7K, so it's not a pair of N7Ks with back-to-back VPC. Just keeps it a little simpler for the external routers or the external N7K that we'll be taking a look at the routing table. And you can see by the color code we're going to be doing EIGRP. Now essentially what this is layer 3 over layer 2. So because we're going to be routing over the VPC member ports, we're going to essentially need to peer our SVIs. So one of the things that we're going to set up, or actually have really set up, is our interface VLAN. And as we set up our L3 out, we're specifying, instead of routed interface or routed subinterface, we're specifying an SVI. So when we create our SVI, we're going to create a single IP address on leaf 1 of 63.63.1.101/24, and on leaf 3 as 63.63.1.103/24. Now, whenever we configure a SVI for regular internal ACI subnets, note that all we do is specify the gateway, the IP address, right, of the gateway and our slash notation, or dotted decimal notation if we want to for our mask. And that instantiates a single IP address, unless we have multiple, then it's a secondary. But that instantiates a single IP address on one SVI across all leaf switches where we have EPGs in that bridge domain, and it instantiates the VRF as well, of course, that the SVI is a member of. But that is anycast IP addressing. When we do L3 out and we specify SVI, it's a little bit different. So we actually have to, and we'll go into this in the demonstration portion after our module, after our lecture portion here, but when we go into this, we actually have to specify that the SVI IP address for our first leaf and our second leaf, assuming that we have 2 leafs for instance, VPC, they're going to have separate unique IP addresses. And then if we want them to have a shared IP address, we create a secondary IP on both of them that is the same IP address. So do take this to note. If we, in fact, let's just pop over to our whiteboard and demo this. Let's just hide this layer. If I have leaf 101, I'll just say leaf 1, and let's just say leaf 3, and I go ahead, actually, let's just draw this a little bit higher. So leaf 1 and leaf 3, or 101 and 103. And let's say I have a VPC peer link down to my 7K, like we're doing here. When I create my SVI on each of these, I'm going to give these the unique addresses. So I have 63.63.1.101/24 and 63, you know what, I'm just going to put this outside, 63.63.1.103/24. And then I'm going to have my shared or secondary IP, and we didn't necessarily see this, so we don't have to do this, but if we do want to have a shared IP address, especially if I have two devices outside and I only, or even one device, and I only want to point my, especially static routes, I want to point them back to a single IP address, this is what I would do. So for instance, I would create my secondary IP as 63.63.1. Let's say 1/24 and 63.63.1.1/24. So do keep in mind this is very different from our traditional subnets where we create a single IP and it's the single Anycast IP address with the same MAC address. These SVIs are different for the L3 out, and I have to use my secondary as the same IP. Now, what this is not HSRP or VRRP. Really, it's not any sort of first hop redundancy protocol. Okay, so it is not this. It is still Anycast, but just kind of a nuance of the way that we have to program this in ACI is we have to use that secondary IP if we want a single sort of a virtual IP or a floating IP. Okay, so the VRF we're going to be using is called MB-L3-Tran. Actually, that's the name of the tenant. And then the private network is L3-Transit. So together they create the concatenation of the VRF name MB-L3-Tran : L3-Transit. So that's where our SVIs live that we're creating for the L3 out. Over on the N7K side, we see that we have an interface port channel 2100, and the VLAN that's allowed, or VLANs, is 2100 and 2200. And the SVI is 63.63.1.7. And we see that we happen to be running it inside of a VRF. It doesn't really matter because we're not running MPBGP. We're not exchanging route target or route descriptor, route distinguisher, sorry. I always say the wrong name. So we are running IP router EIGRP for the AS of 2200 on that SVI 2200 for VLAN 2200. Okay, so we have our IP address set up. It's on the same network, 63.63.1.0/24. And we're going to be advertising loopbacks. So we have 16.16.16, 17.17.17, and 18.18.18, all .0. And for the time being, all /24. We may change that in a little bit. Okay, so that's our EIGRP setup. On the other side, we're going to be doing, in yellow here, OSPF. So I see leaf 2, or 102, has a single routed interface, and the routed interface is 52.52.1.1/24. Could just as easily be /30. Now today, ACI, by the way, cannot do or doesn't support /31s for point-to-point, which is frustrating because they're a lot better use of space, no network address, no broadcast address. We don't need it on a point-to-point network, but we do at least support /30s. We chose just to keep it simple, and we have a /24, although we don't necessarily need it. And we have 52.52.1.2/24 on the Nexus 5K, which is a routed interface as well. So then on the 5K, we're going to be doing, of course, OSPF adjacency with our leaf 2, and we have two loopbacks, 33.33.33.0/24 and 34.34.34.0/24, and we've chosen to go ahead and use area 1, or 0.0.0.1, same area, on both leaf 102 and N5K. Okay? So we're not even doing any ABR. We don't have an area 0, which is fine because we only have one area. We're just keeping it simple for right now and going to be demonstrating essentially getting these routes of the 33 and 34 subnets from the 5K into the ACI fabric and then back out to the 7K, and then vice versa for getting the 16, 17, and 18 networks from the 7K into the ACI fabric in leaf 101 and 103, and then back out leaf 102 to the 5K. And of course, the 5K should also see the public subnets of 11 and 12, and the 7K should also see the public subnets that are inside the ACI fabric of 11 and 12. Now we've set the stage of essentially how we've gone ahead and configured the L3 out. And now we're just going to take a look at essentially making sure we have neighborship from an OSPF and an EIGRP perspective, and then how to configure transit routing. So we're not going to go into the configuration of setting all this up right now, or the step-by-step screenshots of that. We will do all of this in the demo. Okay? So we're just providing this so that you have a kind of a graphical representation in the slide deck and in the lecture portion, and then also we'll go into full setup from the from nothing to 100% setup in the demo sections.